Okay, so now we continue with where we ended. So basically we did this particular question. So remember, now we have 98 and 74. So oh, by the way, in the first one I didn't indicate whether an overflow was occurred or not. Okay, don't worry, so we'll explain in this next video, or in this same video, by the way. So remember, the question was still telling us to add the following numbers in 2's complement using 8 bits. So now the numbers which we have been given is 98 and 74. 98 and 74. So take note of that. So 98 and 74. So let me just write them somewhere so that we don't forget. 98 and 74. Alright, so remember, the first step is to come up with the powers of 2. So 1 times 2. So let me not start from there, we need some spacing. So we'll say 1 times 2, it's 2. 2 times 2, it's 4. 4 times 2, it's 8. 8 times 2, it's 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2, it's 128. Okay, so we have our 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Now remember what I said about complements. I said only negative numbers are affected. In this case, both numbers are positive numbers. Okay, so we just need to convert them in binary the normal way. Okay, so let's start. Here we say, let's start with 98 itself. So now for us to get 98, we say 64. Okay, if I say plus 32, it's 96. So we're just okay. So we have 96 plus 2, 98. So this becomes a 0, 0, 0, 0, and that one is 0. So here we say we have 98. Okay, now we have 74. So for us to get 74, we say 64, okay, plus 8. So 64 plus 8 is giving us 72. Then 72 plus 2 is giving us 74. Okay, so there we go, we have our 74. Now remember, as I've said, these both numbers are positive numbers, so there's no need to apply 2's complement, even though the question is saying add these two numbers in using 2's complement. They are not affected by the principle because they are positive numbers. So here we just do the normal addition. So say plus. So for this one, we are lucky, we just need to do it fast forward. So what is 0 plus 0? This is just 0. As I've said in the previous video, 1 plus 1, it's a 0 and then carry a 1. Okay, so 1 plus 0 plus 0, we get a 1. 0 plus 1, we have a 1. 0 plus 0, we have 0. Then 1 plus 0, we have 1. Then 1 plus 1, we have a 0, then carry a 1. Okay, so 1 plus 0 plus 0, we have a 1, like that. Now, since in the first video I had forgotten to talk about the principle of an overflow. So how can we know that an overflow has occurred? So when we started calculating, we need to understand, for us to come up with 98, our one was, this was our first binary. Okay, so we need to put a demarcation for that number, which is a bigger number, such as 98. We started here, so we'll put a demarcation just there, like that. So we'll say this is the sign and this is the magnitude. So let me explain. So the sign determines whether it's positive or negative. Then the magnitude is the actual value of that binary. Okay, so for this to make sense, I'll ask a question: what is 98 and 74 in normal calculations? So we'll say 98 plus 74. Okay, 98 plus 74. So 8 plus 4, it's 12. So 2 carry 1. The 9 plus 7, it's 16. Plus that 1, 17. We have 172. So this value 172 is still a positive. Okay. Now in binary, a 1 represents a negative and a 0 represents a positive. So if we are saying this is the sign, it means that this is a negative. So we can see that instead of getting a positive number, we end up getting a negative. So it means an overflow has occurred. Okay, but before we even proceed, if we are confused, let's first try to confirm if this number is truly 172. So this is how we do it. For us to get 172, let's just consider where there are zeros, so where there are ones. So here we have a 1, so we have 128. So take note, we have 128. Here we have a 1, we have 32. Here we have a 1, we have 8. Here we have a 1, we have 4. So 128 plus 32, if I'm not mistaken, is supposed to be 160. Okay, so there we have 160. So 160 plus this 8, we have 168. 168 plus this 4, we have 172. Now you can see that we have the correct number, which is 172. But in binary, I've said a 1 represents a negative, meaning even though this is 172, it's showing as if it's a negative number. Hence, an overflow has occurred. Okay. So my name is Asoko James, representing KMU Cybersecurity Tutorials. That's it for this video. So you'll be understanding as we progress with this test 2 paper. Thank you.